So hi, today we are doing more concept. So as a recap, so as you can see, remember that there's this hack over here. So remember this hack is amazing. You with this hack you can actually do all the more concept questions, including JC level questions when you go JC lah. So as a recap, let's try the question. So the question will be, what is the number of ions in FeCl3 in 2 moles of FeCl3. So first type of the hashtag here is right balance equation. So they're asking for ions. FeCl3 is not an ion. So FeCl3 gives you Fe3 plus Cl minus, and you balance it. And you notice that the question didn't ask for a specific type of ion. It's asking for ions in general. So actually, you can actually rewrite this as this gives you 4 ions in general. So first step, you are done. Second step, change to mole. You are already given mole, so it's fine. And third step, you can just do your mole ratio. So 1 FeCl3 is to 4 ions. So there's a times 4 factor here. So mole of ions equal to 4 times 2 equal to 8 mole. And lastly, the number of ions would be 8 times the Avogadro number. So this is a typical question, and this is 2 marks. Quite simple. Okay, so moving on, let's take a look at this. Your molar mass. So molar mass is something that we have done before. So actually we represent this as your AR, MR. It's a similar term. And from this you can see the AR is 27, whereas the molar mass is 27 gram per mole. So the relationship to come out of this is actually this. So please note down this formula, where mole equal to mass over AR or MR. So as you can see here, this is an example of how do you use it. So do take note, mass is in gram. In physics, mass is in kg. So in chemistry, we tend to use it in gram. So do take note, this is a common thing to take note. It is a trap sometimes. So there's another question here. And there's another question here. Okay, so now what's going to happen is, let's try combining both equations. So the two equations you learn now is mole equal to number of particles divided by the Avogadro number. So this is referring to your ions, molecules, atoms, or essentially things that you cannot see, microscopic. And the second formula that you learn is mole equal to mass over AR or MR, depending on whether it's an atom or a molecule. So atom means it's alone. For example, Mg is an atom. AR is an atom. Molecule means more than one. So perhaps NaCl, MgCl2, CO2, for example. So how would a question that combine both of them look like? So the question goes like this. Calculate the number of atoms, hydrogen atom, in 36 grams of water. So the key thing is don't panic. I think it's easy to panic and don't know how to do. So take it step by step. So perhaps, okay, I will go through this question with you first. You try and follow, after which I'll have more questions. You can try them and give yourself time in between to try before looking at the answer. So you can pause the video later. So first step, equation. Alright, equation. So H2O gives you, so the question is asking for atom, or specifically hydrogen atom, H. So remember to balance the equation. Oh, so the thing that we're looking for here is this 1:2. Okay. Second step, change to mole. So mole of water 36 divided by 2 bracket 1 plus 16 equal to 2 mole. Then the third step of my hashtag hack is ratio. So you can see here is 1 H2O is to 2H. So 1:2, so it's a times 2 factor. So mole of H will be 2 times 2. It gives you 4 mole. And you are almost there. Number of H atoms, 4 times 6 times 10 up and 23 equal to 2.4 times 10 out 24. So you might be wondering, must I leave my final answer in terms of SI unit? Or rather, SI units, yes. In terms of standard form, no need. So even if you want to write your answer as 24 times 10 out 23, it's not an issue. So this is how a typical question looks like. So this will be 1 mark, 1 mark, 1 mark. It can be a 3 mark question. Okay, so now let's try another question. So now this question looks like this. Calculate the mass of 1.8 times 10 power 24 carbon dioxide molecules. So now you should pause the video and try it yourself first. So you pause now, pause. When you are done, you can unpause. Okay, so now you have unpaused, you have tried it on your own. So now let's go through it. So first step, equation. So you actually don't need the equation because it's molecules. CO2 is already a molecule. So there's no need for any ratio. Second step, change to mole. So mole of CO2 is 1.8 times 10 power 24 divided by the Avogadro number gives you 3 mole. Then you can convert. So the mass of CO2 will be 3 times the MR, which is 12 plus 2 bracket 16, gives you 3 times 44 equal to 132 gram. So this is how another question looks like, and this is 1 mark, 1 mark. So this is how you can do this kind of questions where you integrate both together. All right. Okay, moving on. So for those who are more inclined to remembering formula through triangles, you may want to copy down this triangle if it helps you. Personally, it doesn't help me, but each to their own. So as you can see, this is another question for you to look at. So any time you need to pause the video, go ahead, pause the video. Don't worry about it. Okay, next portion we are going into percentage composition. So big words, but don't be fearful about it, because this is essentially asking you about percentage by mass. Meaning, for example, let's consider a pie. How do we find out how much meat is there in the pie? Ideally, we want to say, oh, it's 100%. But we do know that it's impossible. There's the crust and all those. And usually there's a lot of air as well. So you can find out the mass of the meat. And you can... So the percentage of meat would be the mass of the meat over the mass of the entire pie times 100%, of course. So this idea of percentage in terms of mass is what we like to do in chemistry. Compounds especially, because we do recall the difference between a compound and a mixture. Mixtures are not fixed ratio. So which means the ratio is useless to us. Whereas compounds have a fixed ratio. So this is the formula. Honestly, you don't have to memorize this formula. You do a few more questions, you should be able to do properly. So let's take a look. So in this case, H2O2. So they want you to find the percentage by mass of hydrogen. Alright? So the percentage by mass of hydrogen would be, so you can see there are 2 hydrogen here. And we know that 1 hydrogen is 1 gram. So 2 hydrogen is 2 times 1. So this is like the percentage meat, the mass of the meat, over the total mass, which is the MR, 21 plus 216 times 100% and gives you the final answer of 5.9%. So this is how you can calculate. Yep. So next, how do you find the percentage of water in this thing? So it's CuSO4 dot 5H2O. So what we will do is we find out the water component. So percentage of water would be 1 water is actually 2 bracket 1 plus 16, the MR of water actually, times 5 divided by the total mass Cu is 64, S is 32, 4 times 16 times 100%. That would give you a final answer of 36%. So that's how you can use the percentage by mass. Alright. Okay, moving on. So now that we know how to do this percentage by mass, we can proceed on to approach what we call empirical formula, molecular formula. So when you see the word empirical formula, don't panic. Simply associate the word empirical to the word simplest. And so in a sense, think of it as simplest formula, whereas the molecular formula means the actual formula. Let's have an example. So the example here, right, is H2O2. So H2O2, the molecular formula is H2O2. This is the real formula. But how do we determine the empirical, meaning the simplest? How do you simplify H2O2? It's like maths. 2 over 4, you will simplify it to 1 over 2. The same idea in maths, you apply it here. So therefore, empirical is just HO, HO. So simplest formula doesn't exactly tell me what it is, but it still has some use to it. Another example, what about C6H12O6? So that is the molecular formula or the real formula. If you simplify it, you realize it's CH2O. One more example. What if it's MgCl2? You realize you can't simplify it, which is perfectly fine. Nobody says that the empirical and the molecular must be different. They can actually be the same. It's not an issue. So you look at the steps here and you might start to panic. Again, what I will tell you is don't panic. Remember the hashtag hack. So whenever you see the word empirical formula, you know that one thing you need to do. You need to have a table. I mean, not this kind of table, like you need to show a table. So I'll show you what the table is. So this is how the table look like. So don't need to panic in the sense whereby you don't know what exactly you should write down. So you are given mass. Alright, let's just write mass. So this can also sometimes be or percentage by mass. They mean the same thing. So I do need to give you a qualifier. Why is it I can do that? So whenever it is percentage by mass and I just put it down, there is an assumption here. The assumption is we are dealing with a 100-gram sample. Meaning, so let's say it's the same, okay, let's say we have an example here. CaCO3. So CaCO3 has an MR of 100. And let's say I tell you that this is 40% by mass. Carbon is 12% by mass. This is 48% by mass. So your table will look, so assuming there is 100%, right? That means 40% will give you 40 gram. 12% gives you 12 gram. 48 gram. So this is an assumption that we do, and we automatically assume, and we don't have to prove it to them. Don't worry. So first step, mass or percentage by mass. Second step, honestly, this one you don't write, right? It's up to you. This particular line is optional. So remember your hashtag hack equation. So remember the hashtag hack, equation, mole, ratio. Realize here, this is mole. You are changing to mole. Then you are changing to ratio. So actually, it's the same as your hashtag hack. And this table itself is already 2 marks. So, and I can guarantee you, empirical formula is something that they will almost always be tested. So it's essentially a free 2 to 4 marks. Alright, so let's take a moment to digest. So therefore, you calculate and you get MgO. Can? Alright.